In the world of aviation, there are details that passengers don't immediately notice, but have a big impact on the performance, safety, and maintenance of an airplane. One of the most impressive achievements in modern aircraft engineering is the Airbus A380, which is considered one of the largest commercial passenger planes ever made by humans. So in this breakdown, we'll look at some unusual engineering facts hidden behind this massive aircraft. Before we begin, please like and subscribe to this video. It means a lot to us content creators. Thank you. And now, let's get started. Number 8. There are airplanes that are not only hard to build. It turns out even figuring out the process for building them is difficult. That's the story of the Airbus A380. Before it could fly as a fully completed aircraft, it started out like a puzzle, divided into different parts across various countries in Europe. Different parts, different factories. Some make the wings in one place, the fuselage in another, and the final assembly in a different country. The final assembly is done in Toulouse, France, a major aviation hub where all the large parts of the airplane are brought together. But what's truly amazing isn't just the assembly, but also how the parts are transported there. The fuselage sections alone, the large cylindrical parts of the airplane's body, are so big, reaching over 20 feet in diameter, that they can't be transported by a normal logistics system. That's why Airbus created a multi-stage transport network that combines ships, rivers, and roads. First, the large parts are placed on a special cargo ship that travels by sea to southern France. From there, they are loaded onto large flatbed trucks that were specially made to handle the extreme weight and width of the cargo. These trucks move slowly, sometimes at almost walking speed, as they travel the more than 150-mile route to the assembly plant. This is even done at night. Because of the size of the parts, they can't travel during normal hours since they would block the entire road. In some places, the actual infrastructure even needs to be modified. The roads are widened, intersections are adjusted, and some bridges are modified just so the convoy can pass through. According to aviation logistics reports, these convoys even became a local curiosity because the parts they carried were so huge, it was like a moving building in the middle of the province. There were also parts that couldn't be transported on the road. For smaller components, Airbus uses its special transport aircraft like the Airbus Beluga XL, a whale-like plane designed to carry large aircraft parts. But even though the Beluga is that big, it still has its limitations. The largest parts of the A380, especially the wings and major fuselage sections, usually still don't fit in the plane. That's why the combination of ship, barge, and road convoy remains the main method of transport. As a result, before an A380 is assembled in Toulouse, each of its parts passes through 3 countries and 2 bodies of water. It's an engineering project that's not just about the airplane, but about the entire global system that needs to move, just to make it happen. 7. When people talk about large airplanes, most people automatically think they're noisy, heavy, and you can hear them taking off from far away on the runway. But in the case of the Airbus A380, the opposite is true, and that's one of its most remarkable design goals. It's one of the largest commercial aircraft ever made by humans. But at the same time, it's also one of the most carefully designed, quietest airplanes in its class. Its quietness is no accident. It's part of a core engineering decision of the entire program from the very beginning. In the aviation industry, airplane noise is important because it directly affects airports and the surrounding communities. If the aircraft is too noisy, its operating hours may be limited, flights may be reduced, or airports may impose higher noise fees. That's why in the development of the A381, of the main goals was to reduce engine noise and the overall sound footprint. According to aviation engineering studies, the A380 uses high bypass turbofan engines like the Rolls-Royce Trent 900 and the Engine Alliance GP7270, which are more efficient and quieter compared to older generation engines. The principle here is simple but effective. More air passes outside the engine core than through the actual combustion chamber. This means that more slow-moving air creates thrust, and this kind of airflow is quieter compared to the high-speed exhaust noise of traditional engines. Aside from the engines, there are also special acoustic materials inside the engine casing that absorb sound vibrations before they spread to the surroundings. The wing design of the aircraft is also optimized to reduce aerodynamic noise, especially during landing and takeoff phases when the airplane is close to residential areas. Even the landing gear, which is usually loud on other large aircraft, has aerodynamic coverings to reduce air turbulence as the airplane descends. Overall, the result is an aircraft that is quieter than you would expect for its size. At major airports like London Heathrow, Singapore Changi, Dubai International, Frankfurt, and Sydney, community noise assessments have noted that the sound profile of the A380 is more acceptable compared to older jumbo jets, like the Boeing 747. Inside the cabin, especially on the upper deck, the quietness is more noticeable while at cruising altitude. Conversations are clearer. The environment is more relaxed and the cabin noise is more controlled compared to older aircraft designs. For an airplane that weighs as much as a small building, the concept is quite unique. It doesn't roar through the sky. Instead, it almost just quietly passes above the world. Number 6. In the world of commercial aviation, what we usually think of are seats, aisles, food, and some entertainment screens. A whole new level of possibilities opened up because of one thing: size. It has a cabin floor area that's almost as big as a small house, and it has 2 full passenger decks that provide space never seen before in previous commercial aircraft. Because of this, the concept of air travel changed. It's no longer just about transport. It became like a flying hotel. One of the very first to use the full potential of this aircraft was Emirates. With their A380 fleet, they introduced onboard shower suites for first-class passengers. This is not just a simple lavatory. These are fully designed shower rooms with heated floors, illuminated mirrors, and controlled hot water supply coming from the aircraft's onboard systems. Shower time is limited because water and weight distribution need to be managed while at cruise altitude. But even so, it has become a symbol of the luxury aviation experience. Aside from the shower suites, Emirates also installed an onboard lounge on the upper deck. It's a social space where business and first-class passengers can relax, enjoy light snacks, have drinks, and chat while in the middle of the flight. It's like a small bar inside the airplane, a concept that was once thought impossible in commercial aviation. On the other hand, some airlines push the idea of privacy even further. Singapore Airlines introduced enclosed suites with sliding doors, a personal wardrobe, and a full-length bed. There are even configurations where 2 suites can be combined to create a double bed setup. This is a rare feature in commercial aviation. There are other airlines like Etihad that even went as far as offering a residence concept. It's a multi-room private space like an apartment inside the plane. This includes a living area, bedroom, and a private bathroom with a shower. According to aviation reports, this level of luxury only became possible because of the unmatched cabin volume of the Airbus A380. But this isn't just a simple luxury upgrade. It also involves heavy engineering, especially in the water systems, drainage, and weight management of the aircraft. Because in aviation, every added feature comes with added complexity. So behind the showers, lounges, and private suites, there's an entire engineering system working just to maintain the stability of the plane while flying high in the sky. Number 5. When looking at a massive airplane like the Airbus A380, it's easy to think that all of its parts need to be extremely rigid and almost immovable. But one of the most fascinating features of modern aircraft engineering is the opposite. The wing is not rigid. It's flexible. Each wing of the A380 stretches to about 261 feet from tip to tip. It's even wider than a football field when you look at the scale. In its construction, a combination of aluminum alloy is used, and carbon fiber reinforced materials to achieve the right balance of strength and weight. Here, the engineers have to make a critical decision. The wing shouldn't just be strong, it also needs to be lightweight. Because in aviation, any additional weight has a direct impact on fuel efficiency and performance. And this is where the wings do something unexpected. In actual flight conditions, as the airplane ascends and the lift force increases, the tip of the wing can bend upwards by about 13 feet. This means that it can bend upwards by about 13 feet, which means that the wing is literally moving and adjusting to the force of the wind. You can especially see this during takeoff, when the lift is just starting to increase and the load shifts from the landing gear to the wings. This is not a design flaw. This is an intentional engineering feature. If the wing is made too rigid, it would need to be reinforced a lot, resulting in a heavier structure and higher fuel consumption. Instead, the engineers allowed controlled flexibility. When there's turbulence or a sudden gust of wind, the wing bends to absorb the shock before returning to its normal position. It's similar to the principle of a fishing rod. It doesn't stiffen against the force, but rather moves with it to avoid breaking. During the aircraft's testing phase, the wings were also subjected to extreme structural load tests at the Toulouse facility. Here, the wings were deliberately subjected to forces much higher than any normal operational condition. That's about 50% above the maximum expected stress. Using hydraulic systems, the entire wing was pulled upward until it reached an extreme deflection of about 24 feet. At that point, the structure reached its failure threshold under laboratory conditions. But it's important to note that those loads are beyond anything that would ever be experienced in an actual commercial flight. The purpose of this kind of test is not to see when it will fail under normal use, but to show how large the safety margin is. And in the case of the Airbus A380, it's clear that its wings were not just made for flying. They were also made to adjust, flex, and survive forces beyond what is normally encountered in aviation. Number 4. In aviation, it's not just the airplanes that need to adapt to technology. Sometimes the whole world needs to change as well. That's what happened with the arrival of the Airbus A380. When it was first introduced, a major problem quickly became clear. Most airports were not prepared for its size. Its wingspan alone, which reaches about 261 feet, already exceeds the standard design of many airport gates, taxiways, and runway layouts that were based on smaller wide-body jets, like the Boeing 747. But the problem isn't just the wingspan. The landing gear of the Airbus A380 can support a maximum takeoff weight of around 560 tons, supported by 22 wheels. This means it puts a different level of pressure on runway and taxiway surfaces compared to previous generations of aircraft. That's why a lot of airport infrastructure had to be assessed and upgraded. In many cases, simple adjustments weren't enough. It was really necessary to widen the taxiways, strengthen the pavement, and change the spacing of the gates so the aircraft could pass through and maneuver safely. There's another major factor, the engine thrust. During takeoff, the jet blast from the 4 engines, and those large engines are so powerful that they require safety zones and blast protection areas that are wider than those used for other aircraft. Because of this, it's not just the engineering of the airplane that's affected. Even airport design standards, operational procedures, and safety planning all had to be updated. At some major airports like London Heathrow, the terminals and taxi systems were designed with the Airbus A380 in mind from the very beginning. There are dual-level boarding bridges that can connect to the upper deck and main deck at the same time, a feature that's rare in aviation history. At Los Angeles International Airport, the Tom Bradley Terminal also invested in upgrades to meet the requirements of A380 operations, including reinforced gates and wider taxi lanes. At Dubai International Airport, this aircraft became central to the design of Terminal 3 and Concourse A, where the entire system was optimized for high-volume A380 operations, including the emergency response systems. Upgrades were necessary because the height of the aircraft's upper deck is around 25 feet from the ground. Not all standard airport rescue equipment can immediately reach it. That's why even fire trucks and rescue ladders had to be modified and upgraded. In other words, the Airbus A380 didn't just enter the aviation system. It forced the very system that would receive it to change. An aircraft that was not just a product of engineering, but one that also drove airport infrastructure to evolve worldwide. Number 3. This program is one of the largest industrial investments in European aerospace history, with development costs estimated at around $25 billion, according to industry reports. The outlook back then was clear. The future of long-haul aviation was centered on large aircraft that would carry more passengers to a few major hub airports. Because of growing demand and congested airports, the logic was simple. Bigger planes, more passengers per flight, and more efficient use of slots. On paper, the concept looked perfect. The Airbus A380 was designed to carry more than 800 passengers in a high-density configuration, or around 400 to 500 passengers in the typical three-class layout used by most airlines. But while the largest passenger aircraft was being built, another major change was quietly happening in the industry. Other manufacturers, instead of joining the super jumbo trend, went in a different direction. This was led by Boeing with the development of the Boeing 737 Dreamliner, smaller, lighter, more fuel efficient, and more flexible in route planning. The concept was no longer to carry more people on a single flight, but to provide direct flights even if the large plane wasn't full. This is where the entire airline strategy began to change. Instead of passing through hub airports, point-to-point routes became more common. Direct flights from one city to another, like Austin to London or Perth to Europe routes. The effect of this was a gradual decrease in dependency on the hub-and-spoke model, which was the design logic behind the Airbus A380. As the use of modern twin-engine aircraft, like the Boeing 737 Dreamliner and Airbus A350 expanded, airlines became more flexible with their route networks. It became easier for them to open new destinations, and they no longer needed to fill a very large aircraft just to make the route profitable. Along with this, long-range safety regulations like ETOPS rules also improved, allowing twin-engine aircraft to fly long ocean routes that were previously exclusive to four-engine jets. Over time, airlines chose flexibility over maximum capacity. Passengers also preferred direct flights over connecting hubs, and gradually, the economic case for super jumbo aircraft weakened. In 2019, Airbus officially announced that they would stop the production of the Airbus A380. According to reports, one of the main reasons was the reduction of orders from Emirates, which was the largest customer of the aircraft. In total, only around 251 units were delivered worldwide, which is far from the original projections during the development stage. In the end, the A380 remains a paradox in aviation history, an engineering masterpiece that changed the standards of aircraft design. But at the same time, it also became a symbol of how sometimes technological perfection is not enough when the world changes course. Number 2, at the start of the global pandemic in 2020, almost the entire aviation industry came to a halt. International travel collapsed and many airlines were forced to reduce their fleets to cut costs. During that time, many A380 aircraft were removed from active service. Some were sent to long-term storage sites in the desert, places in Spain, central France, and the American Southwest, where the dry climate is favorable for storing large airplanes. There, they are lined up on long stretches of tarmac, stationary, with their engines covered like giant machines that have fallen asleep. Some aircraft were never brought back. According to aviation reports, some units had their parts removed and were used as sources of spare components, while others were eventually scrapped because reactivation cost more than operating them was worth. These images became the symbol of an era. The sudden halt of global aviation led many analysts to say that the era of super jumbo aircraft seemed to be over. But the story changed by the time 2022 and 2023 rolled around. International travel returned and demand didn't just come back, it exploded, especially on long-haul premium routes. Routes like London to Dubai, Sydney to Singapore, and Frankfurt to New York quickly filled up. At that point, airlines noticed that the smaller wide-body aircraft didn't have enough capacity. This is where the A380 reemerged, not as an outdated machine, but as a solution to the sudden surge in passengers. The only problem is it's not simple to return a parked aircraft to service. Reactivating the A380 is a complex engineering process. The entire airframe needs to undergo a full inspection. The engines are restarted and tested, and if necessary, completely overhauled. The seals that dried out while in storage are replaced. The hydraulic systems that haven't been used for a long time are repaired and inspected, and they will undergo complete flight control testing before being allowed to fly again. According to aviation maintenance standards, this process can take several weeks to several months depending on how long the aircraft has been in storage. But even so, it still became economically viable for many airlines because the profit from high-demand routes is higher than the cost of reactivating the aircraft. Some airlines reversed their decision. The previously retired A380s were brought back into service for long-haul operations. Some carriers deployed them on routes to Asia and North America from their major hubs. Others were used for charter or wet lease operations, where maximum passenger capacity is important. And in the midst of all this, the commitment of Emirates, one of the largest operators of the A380, remained stable, as they continue to use it as a core aircraft in their long-haul network in the coming years. The most important lesson from the comeback of the A380 is not technical, but economic. In aviation, the most efficient on paper doesn't always win. Sometimes the most practical wins when demand returns at a scale that only large aircraft can handle. Number one, there are machines in aviation that are not just products of engineering. Sometimes they are experiments to see how far humans can push the limits of design, economics, and the needs of the world. That's the case with the Airbus A380. With its size, the complexity of its systems, and the number of its parts, it's an aircraft that seems to have been made for a different era, not for the aviation market that exists today. In the modern aviation industry, flexibility is now more favored. What's more important now are more routes, more airports that can be served, and more efficient operations using twin-engine wide-body aircraft, like the Boeing 787 Dreamliner and the Airbus A350. The direction of the industry is clear: smaller, more efficient, more adaptable. With these changes, it gradually became clear that the concept of the super jumbo aircraft was no longer compatible with the new global travel system. But despite this, the huge contribution of the A380 to aviation history cannot be denied. According to aviation records and industry data, only a few hundred units were produced, and each one is made up of millions of components from hundreds of suppliers in different countries. An entire engineering network is needed to build each aircraft. When it passes through the airport, it's not an ordinary sight. Even from a distance, passengers, ground crew, and even pilots of other planes can't help but look. In aviation, it's rare for something to truly make people stop and stare, but the A380 does that, not because of its noise, but because of its scale. An aircraft that's closer to a floating structure than to an ordinary plane. As time goes by, the economics of aviation become clearer. Airlines are increasingly favoring aircraft that can operate more frequently, are more flexible, and are easier to fill with passengers. That's why designs like the 787 and Airbus A350, which are more suited for point-to-point travel than large hub systems, remain dominant. In this kind of environment, the truth becomes clearer. The Airbus A380 did not become the standard of the future. It became the last major expression of an idea that the solution to air travel was to make aircraft as large as possible, up to maximum capacity. But over time, this was replaced by a more practical approach. However, its story isn't over yet. In the coming years, many Airbus A380s will continue to fly on long-haul routes, especially in high-demand corridors, where volume is more important than flexibility. And someday, its final flight will come. One landing, one taxi to the gate, and a moment of silence after the engines are shut down. It won't just be an aircraft coming to an end, but an entire era of aviation design. That was the time when the world tested how big an aircraft humans could fly and how far an idea could take us. And if you think about it, the A380 is not just an airplane. It's a reminder that in aviation, you don't always win. The most practical at first, sometimes the most ambitious, becomes the most iconic. In the end, it's not just about the size of the aircraft, but the size of the vision behind why it was made.